This unit is on functions. A majority of this unit is taking a look at vocabulary and applying it to things that you've actually already learned. When we look at a function, it's going to be a relationship that pairs each input, which is your x value, with exactly one output, which is your y value. That's going to be pivotal throughout this entire chapter. When we look at a relation, that's going to be your pairs of inputs and outputs. One way we can visually represent ordered pairs, aside from just writing them the conventional way, is to create a mapping diagram. So it's just that visual representation of ordered pairs. So your input value, we're going to see it right here. This is going to be your x value. Think about an equation and think about what the word input means versus the word output. If you have something written in slope-intercept form, it's going to be y equals some value times x plus some other value. Input means to put in something. So you're going to input a value in for x, and it's going to spit out or output your y value then. So when you're looking at a mapping diagram, it's showing you that for the input 1, the output is going to be 3. For the input 2, the output is 6. For the input 3, the output is 9. And for the input 4, the output is 12. So when your x value is 1, your y value is 3. X value is 2, your y value is 6. So on and so forth. So for something like this, you can write the different ordered pairs for it. So the first ordered pair that you have here is 1, 3. Since your input is 1, the output is 3. That's your first ordered pair. The second one is 2, 6. The third one is 3, 9. And then the fourth one, that is a 3, not a 13. The fourth one is 4, 12. Take a look at this next input-output diagram or mapping diagram. You notice that the number 2 has 2 arrows going from it. That means that the different ordered pairs here, the first one I see is going to be 0, 0. The next one I see is going to be 2, 1. And then the next one is 2, -2. So we actually have 2 inputs that are the same, but they have different outputs. So creating a mapping diagram kind of organizes it, and it's a visual way to see it. The last one then would be, yes, 4, -3. So if you're looking at a mapping diagram and you're trying to determine whether this function is a relation or not, is this function a relation or is it not? Every function, here's where some vocabulary comes in. Every function is a relation. So that's a key piece. It is that relation that pairs each input with exactly one output. So your input can only be paired with one output, and that is it. So if you look at this first one, each input here is paired with just one output. So yes, that's considered a relation. Even though 5 and 12 have the same output, they're 2 different inputs though. That's fine. We call this one definitely a relation. Now, looking at the next one, you will see as you go down the line, -2 is with 4, -2 is with 4, -1 is with 3, but 0 has 2 different outputs. This is not considered a relation then, because that input is paired with 2 different outputs. So not a relation. So that's a lot of terminology in this. You have to think about inputs and outputs, and then if the function is a relation or not. So the next piece that we can take a look at is, okay, so now we have that mapping diagram. Let's see if the mapping diagram creates a function. So it says to describe the pattern of inputs and outputs in it. If you have a consistent set of inputs and outputs, then it's considered a function. So taking a look at this first set, your inputs are increasing by 1 each time. So from 1 to 2, it's a +1. From 2 to 3, it's a +1. From 3 to 4, it's a +1. Your outputs then, from 15 to 30, it's a plus 15. 30 to 45, it's a plus 15. 45 to 60, it's a plus 15. So yes, as each input goes up by 1, the output goes up by 15. So this is a function. So when it tells you to describe that pattern, that's what you would say. Yes, because your inputs go up by 1, each input goes up by 1, each output goes up by 15. Looking at the next one, we have plus 2, plus 2, plus 2. Minus 3, minus 3, minus 3. So again, yes, this is a function because each input increases by 2 and the output decreases by 3, or you can say it increases by negative 3. So when you look at an input and output table, or you look at input output table or mapping diagram, you can determine, are these a relation or are they not? Is each input paired with exactly one output? Then yes, it's a relation. If your answer is no, then it's not a relation.